Hello everyone and welcome to Learn Solus Packaging, session 2-1, which is a continuation of session 2. Session 2 went over setting up your environment, setting up Sol build, and just sort of diving into some of the basics of packaging. In this session, we are going to be going over macros and some variables. Before we get started though, I'm going to brush over two things. So what we're not going to be going over or brushing over, and just some basic variables that we'll be using throughout this session. So we won't be going over Perl or cute actionable macros, and we won't be applying patches. The process for applying patches is very simple, and we have documentation on it that you're welcome to review. We covered the CMake actionable macro itself in session 2 when we did the peak example, so we won't be going over that either. That would be redundant. We won't be covering variable macros because we're typically going to be using just normal variables. And we won't be going over emul32, so like generating 32-bit packages and some of the optional keys like replaces. And we won't be hunting down licensing, writing summary, description, any sort of the items that would slow us down. And our focus mainly is the macros themselves. So we'll be going over Haskell, we'll be going over Meson, and we'll be going over Python, and we'll be going over a bit of the GNU build system stuff as well. So let's go ahead, and the second item was these variables. So I wanted to go over workdir, installdir, package files, and sources. So workdir, in its the basic way of describing workdir is where you're going to be doing all of your work. So where the source is going to be extracted, where you're going to be compiling, and then the installdir, you could think of it as the root of the file system as to where everything's going to be installed. So if you have a user folder in installdir, then that would correspond to /user on your host system. And then package files refers to the files directory, which is relative to the package.yaml. We'll be going into package files a bit. And sources is the directory that will contain all the sources that you specify. We won't be going over that, but the basic for that is if you specify multiple and you don't have extract no set, then we will extract the first source. And then what we'll do is we'll store all the others in sources. So let's go ahead and jump into common, like the common stuff that we'll typically be dealing with. So going into it, autogen and configure, which come from the GNU build system, otherwise referred to as auto tools, and make install are typically what we are going to be dealing with. So let's dive into an example. Our example is going to be zsync. So zsync is a file transfer program. The basic of zsync is if you have an older, so you download a version of a file from a remote server. And if you have an older version, it'll only synchronize the diffs. So like the difference between the two. So that's pretty handy. And it's really simple. It's just a configure, make, and make install. And it has no dependencies. And we're just going to chuck it in system.utils. So we already have zsync open. How convenient. So let's go ahead and yep, just double check that. Cool. So we are in our old repository stream folder. We have made zsync. We're going to cd into it. We're going to go get the source. So as you see, I don't know why they put as the older versions and they have 0.62, but it's also the current version, but whatever. I'm going to use my alias. And we have gedit. So we don't need build deps. So let's remove that. We're not going to worry about component, summary, description. And as you can see, it already does the setup, build, and install. So it already has configure, make, and make install. So we already have our make file and our package.yaml. So let's go ahead and just do a build. It would actually help if I saved the package.yaml. And it's done. That took so long, didn't it? So let's go ahead and check out the contents of it. So as you can see, we have zsync, we have zsync make, we have a couple docs, which is the copying and readme, and we have a couple man things as well, the manuals. So let's go ahead and just do a basic example of additional files. So when you're dealing with additional files, you're going to need to create a files directory. And as you can see, assuming you have just an empty dir with like the package YAML and whatnot. Let's go ahead and do touch files example, so that'll create an empty example file. And as you can see here, we have example there. And what we're going to do is we are going to install this just into user shared doc, because I know it exists. Although our install call that we're going to be doing will actually create all the directories leading up to example file, where example file is actually what the name of the file is going to be called. So we're actually changing the name from example to example file during the install. So as you can see here, we are using this package files variable to reference the files directory, and then the content of it is the example file, so we're referencing that. So we're going to go ahead and run make again. Once again, forgot to save. I'm glad I'm picking a very simple example. There we go. Okay, so as you can see here, we have user share doc zsync example file. Now let's just say we didn't want that example file in our zsync package. We wanted to split it off into its own subpackage. How would we do that? Patterns. So what we're going to do is probably after description. We're going to start off with patterns. And what we're going to do is have a list. We're going to have docs here. And then what we do is we could have an array, or we could actually have a sublist in YAML. I prefer to use arrays just because I think it's cleaner. But obviously, if you have 1,000,001 files that you're splitting off, it makes sense to do the YAML like sublists. So we're going to just do user share doc and then zsync. And we're even going to specify that example file. I actually saved it this time. Now if we run make again, and we ls, you see we have zsync and we have zsync docs. And as you can see here, our example file is not in zsync, but it is in zsync docs. So that is how you would do some basic splitting. So next up, we are going to be doing Haskell. Admittedly, I'm not particularly familiar with Haskell packages myself. Brian is the one that has been doing, I don't even know how many Haskell packages at this point, but fortunately, he made some macros to make it really easy to do Haskell packaging. So, or at least to make it easier. So what we're going to do is we are going to use the example Haskell setenv, or the setenv package, and it's a cross-platform library for setting environment variables. Who would have thought? So let's go ahead and do that. So I'm on the package Haskell thing. So let's go ahead and search for a setenv. Now, before I dive into the downloads thing here, I just want to point out that I really like the package page because it lists it lists like the license, and so you don't have to go and dive into it. And it's really easy. It has all the relevant versions and an easy link to the setenv tarball. Good guys. So we're just going to copy a link. So we have setenv here. We're going to rename this. Now, I do want to clarify that if you are going to be doing a Haskell package, the component should be programming.haskell. We have a dedicated component for that. And when you're dealing with Haskell and the Cabal macros, what you need to ensure you do is always have Haskell Cabal install as a build dep as well. So let's go ahead and list that one out. Now, what are the macros we use? So let's go ahead and jump back over to our package.yaml. And as you can see here, we have 4 actionable macros. We're going to be using all of them. So we have Cabal configure, Cabal build, Cabal install, and Cabal register. So Cabal configure is self-explanatory. It configures it with prefix and libdir and so on and so forth. Cabal build builds it. Cabal install actually copies the contents to install dir, and then Cabal register actually generates a package config for the package and the version, and then installs that. So how this would be set up is what we do is in setup we do Cabal configure. In build we do Cabal build. And in install we do Cabal install and Cabal register. Let's go ahead and make sure that's saved and then build it. And as you can see here, we have Haskell setenv and a generated subpackage for devel. And as you can see here, it looks like the normal contents for the Haskell package, at least the content I've seen from packages in the past. Help if I didn't minimize my terminal. And as you can see here, we have a static file now. As far as I know, that is completely normal, so I'm not going to be worrying about that. So next up we have macros for the Meson build system. Now I scoured around for really simple examples, and I found one that was quite surprising, that had a sane build setup, not a lot of dependencies, and it might be something you're very familiar with if you like screenshots and if you like Budgie, is the Budgie screenshot applet by Cyber. So let's go ahead and dive into that. So what are the macros for Meson? The actionable macros for Meson is Meson configure, Meson build, and Meson install. So the configure one will pass along our C flags and things like libdir. Build will just pass along jobs to Ninja to actually build it, and then Meson install will actually run the install with the dester and the jobs variable. However, we have some build deps to do. So let's go ahead and get started with that. Let's go back. So it indicates that we're going to need the package config budgie dash 1.0. We're going to need GNOME desktop 3.0. We're going to need GTK, JSON lib, libsoup, and we're going to need the Vala package as well. Now, I believe, and I will double check, that our budgie desktop devel actually requires libgtk3-devel. Therefore, we don't need the GTK package config. So really all we need is budgie, GNOME desktop, JSON glib, libsoup, and Vala. So let's go ahead and do that. Yep, and as my suspicion was correct, it does of course depend on libgtk3, which would make sense given it's based on GTK3. So we're going to add that package config. It also needs GNOME desktop. Now I'm pretty sure Cyber's already indicating what the package configs are, but it doesn't hurt for us to check. So we have GNOME desktop 3.0. which itself requires libgtk-3. So even if for some crazy reason, like this is Budgie 11 universe or something, which actually it wouldn't need GTK for the applets then anyways, but let's just pretend in some magical universe we have a cute desktop with GTK apps, then even GNOME Desktop would rely on libgtk3, so we wouldn't need to specify that as the package config. So let's go ahead and get the JSON glib stuff. And there we go, there's the package config. We need libsoup. And we need Vala. Okay, so now that we have our build up set up, let's go ahead and deal with those macros. And let's go ahead and build. Has to pull down a lot of depths. Thankfully, a lot of these are cached already though, so. Mesa not found, okay. I just want to double check the dependency there. Welcome to real life packaging. Setup failed, what? Let's go ahead and double check this with the Okay, I might not have that cloned actually. Oh wait, that's right, it's called Screenshot Applet. It was renamed. Ah, yeah, okay. I forgot about the funky business of the nested builders. Of course. There's been instances where that hasn't been required for me, so. Okay, now let's build. Third time's the charm? Maybe. I'm glad this is an SSD, otherwise this would take a long time on my old hard drive. There we go. Now we're actually building. Now we're cooking with gas. There we go. So if we do a ls.eo package on the eo package, we see we have the libdir stuff, we have the app data, glib, and locale. So with Meson out of the way, we have one more to tackle, and that is good old-fashioned Python. And those are always a rabbit hole, but I found one that actually doesn't require any sort of like other Python libraries. So let's go ahead and get that example, which is wc width. And we're going to grab this tarball. Now, for whatever reason, the PyPy folks like to append the source tarball link with the MD5 hash, so we always have to remove that. And here we go. So as you can see, it already added the Python setup and Python install macros. But let's go ahead and talk about those macros. So we have 4 macros. We have Python setup, Python 3 setup, we have Python install, and we have Python 3 install. As you might have guessed, Python setup and Python install is for Python 2, whereas Python 3 setup and Python 3 install is obviously for Python 3, given the name. So for these, what we're going to need for Python setup and Python install is we are going to need the Python setup tools package. And for Python 3 setup and install macros, we are going to need the Python 3.5 package config. So let's go ahead and add those. Now, something that is important to note that if you are doing a Python package, so something that comes from PyPy, the component should always be programming.python. I also want to note that if you are creating a Python package and you only need it for, say, Python 3, then you don't need to use the Python macros. You could skip that. Well, at least the Python 2 specific macros, or if you're generating it only for Python 2, then there's no real sense in generating the Python 3 stuff as well. Let's go ahead and make that. And it's done. And as you can see here, it puts the WC width in the correct Python 2.5 and Python 3.5 locations, the site packages for that. So that is a real basic overview of additional files and actually installing those, and a bunch of different actionable macros, including, of course, the GNU build system, Haskell, Meson, and the Python ones as well. So we have Perl, and we have Qt actionable macros as well. So if you love Perl, then we have an easy way of packaging up those. Or if you love yourself some Qt, we have a qmake and qmake4 macros. The qmake4 macro is actually fairly recent, and it does a lot of the repetitive stuff that we've had to do in the past, which is set the mock, RCC, and UIC flags because our Qt4 executables for those have the appended name, the suffix -Qt4. And we've gone over our variables, so if you're interested in learning more, you could go over to our Help Center. You could go and click all categories. Packaging. As you can see here, we have a bunch of documentation. I would suggest getting started with the packaging guide. And then under the getting started section, we have the package.yaml stuff and the build packages and submitting the stuff, which we covered in session 2. Additionally, if you go under packaging practices, we talk about some of the automatic naming that we do and automatic splitting into sub-packages for devel, docs, 32, and utils. We talk a bit about maintenance, generating a package.yaml, some extra files and applying patches such as CVEs, and then of course the installing of additional files. This would make sense if you're installing custom configs or desktop files or even PNGs for, say, icons. We go over build deps and package configs, of course. Patterns, run deps. We have a lot of content that makes it really easy to get started with packaging, so I welcome you to go over to that and learn more. So thank you for tuning into session 2-1. If this is a bit over your head, then I welcome you to join us on session 3, where we'll be starting from scratch and taking a step further with the packaging. So what we'll be doing is doing this soul build stuff. We'll be doing the setting up our environment, and of course the packager stuff. Alternatively, you can watch a session 2 as well, because not a lot has changed since then. So thanks for tuning in, and bye-bye.